There's the ground-up view of promises as an abstraction in JavaScript. There's a historical perspective on kind of recent things we've been doing in the promise space and kind of how they've gotten so popular in JavaScript and why I think they're kind of the wave of the future. And then also just end with a practical guide on using them in your code. And since we probably will have enough time, there's also like a futuristic, crazy promise tricks section at the end, which, you know, we'll see. We'll see how that goes. It's always kind of out there. But, you know, going into promises as an abstraction, well, okay, first, you know, here's my standard view slide. I have a lot of presentations on promises on SlideShare. If you find this one not edifying enough or not detailed enough or too detailed or whichever, and I have a lot of packages. I maintain the Q package, which is one of the more popular promise libraries, along with its original author, Chris Kowal. Things I'm doing that I think are kind of relevant. I maintain the ES Discuss Twitter account. So there's a mailing list where the inventors of the language and the people in charge of evolving JavaScript discuss, you know, its future and modifications to it and its impact on the web. And it's kind of hard to get into if you're new to this stuff. So I maintain 140 character summaries of it as the mailing list messages fly by on Twitter. I've worked on the Promises A+ spec, of course, very relevant. This is the most recent kind of like specification for how promises should behave in JavaScript, and it's really taken off, and we'll talk more about that later. And finally, at Gotham.js, I gave a talk called ES6, the awesome parts. ES6 is the next version of JavaScript, ECMAScript 6. And it's got a lot of really cool features, and some of them are kind of mundane, things like, you know, finally we get default arguments or whatever, class sugar in the language. But I talked about two in particular that I thought were kind of underappreciated and we're going to change how we program, and those are generators and template strings. So if you haven't really heard about those or gotten into those, you'd enjoy checking that out. Yeah.
Was that recorded?
It was recorded, but it is not posted yet. So we'll see if they post. I'm skeptical. I've been bitten by conferences in the past that say they have not yet. Right. So promises in general. So the promise abstraction, right? I kind of want to give this a theoretical grounding before we go into the nitty-gritty code examples. So the easiest way to motivate them first is to contrast them with the simplest thing you can possibly do, which is callbacks. And this is what you see in most of your JavaScript APIs. You're trying to do something asynchronous, which is basically everything in JavaScript, because you can only do asynchronous I/O. You can't do anything synchronous like you would in block, because there's only one thread. So what you have to do is you have to pass these functions to other functions and say, when you're done doing your I/O, call me back and run the rest of this code. So it's you know, the style called continuation passing style, but it's just completely the simplest thing you can do. It's really a hack. It's shoving code into an argument to a function and saying, call this later. I mean, it's nice because JavaScript gives you the power to do that, but I feel like we've abused JavaScript when we go that route. And part of the reasons why is that compared to kind of traditional paradigms for async operations, you know, there's no consistency when you have a callback API. You could accept a single function that takes an error and a value. You could take two functions, a success handler and an error handler. You could take just a success handler and blow up if there's an error and not tell you. You know, there's no guarantees, right? It might have a bug and call you back with an error and a result. Or it might call you back twice. Like you know, I went to a talk in Shanghai at a conference at Who.js, and about half the talks were in Chinese. And one of the talks that I thought was really fun was, you know, is in Chinese, but there's a lot of code, so I was more or less following along. And it was really cool to see one of the slides, you know, he was like gesturing wildly at this code sample and saying, and it was some code from the depths of Express, a very popular Node.js framework. And what he was trying to show, you know, and I just inferred this, even though it was completely in Chinese, was that this was a double callback bug. That, you know, there was some try catch that caught the error, but it also called it back with the error, and now it was calling back a callback twice. So when you use something as raw as callbacks, you know, even very popular libraries can get bitten by this kind of no guarantees Wild West scenario. But even if apart from just like the code, you know, correctness issues, right? There's the code clarity issues, right? You're writing all these crazy callbacks that just tie together other callbacks and maintain a counter to see how many operations are in flight. You're saying, oh, I want to wait for these two things to finish. Oh, I want to do this after this after this. You never really get a sense of what your code is trying to accomplish because you're just using this basic callback primitive. And even worse, the basic error handling of our language that we're so used to from everything from C++ onwards, exceptions, where it unwinds the stack and lets somebody handle it at some point, somebody who's equipped to, goes away. With callbacks, when you get an error, you have to explicitly pass it up to the next person responsible for handling the error. And we'll see examples of that in a compare and contrast later. But that's kind of the foundational problems that we have when we just do continuation passing style and stuff code into other functions and say, call me when you're done. So promises, I claim they're the right abstraction. And you can see this. So the basic idea is that instead of passing a function like we do in this first example, continue here, you get back a promise for the result. And this promise represents eventually I will have the contents of that file. So the first benefit you can see is we're separating inputs from outputs. No longer are we conflating our input of file.txt with what's actually the output, the result that happens to be actually inside a function that is an input to read file in the first example. But now we have actual return values. So that's nice. But we also get back, by the nature of promises, these guarantees. So the way that you access a promise's value is you have this promise object, right, which we got just in the previous slide by calling the function. And now we call .then on it. And we pass it two functions. One, the onFulfilled handler, for when the promise is fulfilled, and one, the onRejected handler, when the promise is rejected. And the power of promises comes from their analogy with normal synchronous code. The idea is that we maintain the same guarantees that a synchronous code and synchronous call stack would via these kind of guarantees about the onFulfilled and onRejected handlers. So in particular, only one of onFulfilled or onRejected will be called. And this is just like when you have a synchronous function, it will only ever return or throw an error. It would never, of course, do both. And furthermore, onFulfilled will only be called with a single fulfillment value, which is just like the single return value you would get from a normal function. If you want to return multiple things, you would return an array. Same thing with promises, called onFulfilled. We'll call onFulfilled with an array. OnRejected will be called with a single rejection reason, which is just like the throw an exception from synchronous functions. And just like in synchronous functions, it will usually be an instance of error. Sometimes it'll be anything else, but that's bad practice. So the idea then is that if the promise is already, and then we also have this guarantee that if the promise is already settled, if it's already fulfilled or rejected by the time you get it, then the handlers will still be called once you attach them. So if you get this promise and somebody's already fulfilled it, you can still attach an onFulfilled handler and you'll get called. But we guarantee that the handlers will always be called asynchronously. It's kind of a subtle point, and we'll see exactly how that works later. But it's really important for reasoning about your code, because otherwise you don't really know if your callbacks are going to be asynchronous or synchronous. It can interrupt your flow and cause some really subtle bugs. So we've got a lot of consistency and guarantee gains already. Kind of the final, piece of the promises foundation is that you can chain them together. So you have an original promise, right, and you queue up these reactions to its values, the onFulfilled and the onRejected, right? Just like that's the basic thing we did back here. But then we can transform it as a result of what those functions do. So if the called handler, whichever it is, onFulfilled or onRejected, returns a value, then we resolve the transform promise with that value. And resolve is kind of a confusing verb because jQuery uses it to mean fulfilled, and it's everybody's confused. But what it really means is that if the return value from whichever callback is a promise, then we'll adopt its state and we'll wait for it. So if you return another promise, then we're going to wait for that next operation. But if it's not a promise, if it's just like a synchronous value, then we'll fulfill the promise with that new value. We'll see examples of this momentarily. And then, of course, on the other hand, if the called handler, whichever it is, throws an exception, then the transform promise will become rejected with that exception. All right, so let's get into a series of kind of like examples based on this, because all that builds up to, these properties combined give you this sync-async parallel, right? So if you have this synchronous code where you try and do something and store it in a result, and then either handle the error, or if there is no error, then you process the result. That's the same as this promise code. That's the idea behind the then primitive. Then you do the process or you handle the error. So that leads to a series of kind of cases of what promises give you in terms of the translation between normal synchronous code you would write and asynchronous code. So if you have synchronous code that just does a transformation on a value, it gets a user and then it gets its name. In promises, you would write that get user, and you have this asynchronous value, this user promise, and then you call .then, you get access to the actual user object, and you return the user.name. And now, because of that transformation property we were talking about, if you return a value that's not a promise, you get a new promise for the username. Everybody following this? Please ask questions.
So what happens if we get an error trying to get the get user?
Yes. In that case, yeah. That's a great question. So if get user returns a rejected promise, that's how it would signal an error, because it's asynchronous, so it would always signal through rejection. Then the unfulfilled would not be called. So nothing would happen. You would stay with that error inside your username promise. And this is cool. You're kind of jumping ahead of it, but this is like errors bubbling up the stack and skipping all code in between them. So that error bubbles up and is stored in username promise, just like a thrown exception would bypass any code right after it. Question?
I thought you said in the previous slide that if you returned another promise, it would
yes.
become a transform promise. If you turned a regular value, it would be the value. Is that what you're showing here?
That is what I'm showing is the regular value case. Good clarification. So user.name is like a string, right?
So username promise, what you're getting back there, I think the value that gets assigned is going to be a string assignment or a promise?
It's going to be a promise. Because remember, all this code runs like right now, the get user.then. This code runs later, once the user is back. So we have no way of knowing that there's going to be a string. So this is a promise for whatever happens here. And like he said, it could be an error, so it could be a promise for a rejected promise for an error. Or if everything goes well and we get a user, it'll be a promise for the user's name.
So, but the only reason to return another promise would be to perhaps chain it with a different one? Or
yeah, you'll see an example. It's really just a convenient syntax for avoiding a lot of nesting. But yes, it's like if you want to do another async operation based on your current async operation, then you can you could return another promise.
So, if this were a function and we had an error, we obviously aren't going to return username, right? Because we don't have a user whose name to return. We're going to return what?
Okay, I think I'm understanding your question, which is like if we were to wrap this up as some kind of
well, I mean,
get
you
username.
said return, right? So I mean,
yeah. So what you would do is you would return. You would replace this line or this segment with just return, right? So and that would end up returning, or you just say like return username promise, and that would return the original error. It would return the promise with its rejected with whatever the error was.
It's not essentially it's the same way as a mapping and Haskell looks.
It is very closely connected to the monads and that idea in Haskell. Also, I should have mentioned this earlier, it's .NET's task T, if you use those in their raw form.
So that's basically a transformation of a promise that returned a user object to a promise that returned a username.
Exactly. Perfect. That is exactly how I want to say it. And remember, we're trying to emulate the synchronous code. So, yeah.
Just to be clear, can user returns a promise and then returns a different promise instead?
Yes, exactly. Yeah, every promise has a then method which returns new promises, depending on what the behavior of the pass handler says.
Which you can ignore.
You could ignore, but you shouldn't. Talk more later.
So get user is a function which is returning a promise.
Yes. Yes. Good question. Here in synchronous land, it's returning an object. In promise land, it's returning a promise.
Gets used as specifically related to return a promise?
Yes. And there's ways to make that very easy and make it, but we'll see how to create and return promises later.
Did you just say promised land?
Promised land. No, this is promised land. This is synchronous land. How are we doing? Good set of clarifying questions. I like that. I mean, it's much better to be engaged than confused. So we're good. All right, let's try one more. So now we get into the ones with the errors, right? And this is the synchronous idea here is that you do an operation, and you in reaction to that, maybe in some cases, you throw an error. So what we do here in promise land, right, is we say get the user, and then in reaction to that, if the user is null, just throw the error. Otherwise, return the user. So the idea here is that this promise, this user promise, will be rejected with the thrown error if the user that comes back from the server or whatever is null. Otherwise, it'll just be the user object itself. So we're using the two behaviors here, right? The behavior where if you throw, it rejects the return promise, and if you return, it fulfills the return promise.
So rejected promise always returns null, never undefined.
Sorry, no, it doesn't have anything to do with null. So imagine somebody wrote, some people have like philosophical differences against errors, and this person who wrote the server, or maybe, okay, let's put it this way. User may not always exist. A good way to signal that is by fulfilling the promise with null, right? So this get user function always returns a fulfilled promise, but sometimes it's null if there's no user for ID 123.
But what if it's not fulfilled? Anyway.
Well, if get user is rejected, maybe there's a network error, then all this will get skipped, right? That's what he was bringing up last time. It's like the exception bubbling. It'll just skip all this code, and none of this will matter, and you'll get whatever the original rejection was.
Okay.
So is the user promise different than the original promise returned by get user simply by the null handler?
Yes. The original promise returned by get user could be null, right? This one, if it's null, it'll be a rejection. So it'll never be null.
When you're done, the user promise is the user, if nothing goes wrong.
Is a very strong word. Represents is better. Because you can't access a promise's value synchronously in JavaScript. You need to use the then method.
But when I attached the function of user,
Yeah.
okay, made it return user,
Mm-hmm.
then what is user promise if everything goes well?
Once everything goes well, it's a boxed representation of the user. That when you call then, you'll access the user object. Before anything happens, it's a box representation of things waiting to happen, right? It's in neither state. It's neither fulfilled nor rejected. It's pending.
Okay, so you're presumably going to tell us how I would access the user, give an illustration of how to get at that box function, I hope.
So I guess I wasn't that clear on that. You should just be able to use the then method, right? So in this case, let's go back to the simpler example, right? Because it's the same basic principle. The get user function here, not worrying about any of the null cases, will return a promise for a user object. But to access it, to unwrap it, you call .then, pass it function user, and inside this, you see the object. You've unwrapped it using .then. No?
So, but if you were to return the user object itself, and if you need to resolve that promise, do you need to resolve that promise to get that user later on?
So the promise returned by then will be fulfilled if you return, and
Could you
rejected
use
if
the
you throw.
whiteboard to illustrate some of the
Yes,
things?
let's do that.
Dominic, if I may.
Yeah.
I think the confusion is we need a case 0.
Yeah.
You've shown transformations of promises, but what you haven't shown is promise.then.
Yeah.
Just access the value and maybe we put it in a DOM element. Or something like
That's
that.
totally fine. That's a great idea. So let's say, I've been given. Is it okay if I don't show how to create a promise yet, and I'm just given it by some other API, or should I
You
show?
got one right here, right?
Okay. So I have, var user name promise. This is probably too small. Let me start over. Username promise. So I'm going to get it from some other API. Right? So to access that and put it in the DOM, for example, you're going to do unp.then function. JavaScript is verbose. Username. And And then you're going to say like, document body dot inner text equals username. Because inside here, you have access to the string, right? Just like inside there, we have access to the user object. So that's how you unwrap things. But what I'm not showing, right, is the transformation that I'm trying to skip ahead to in my case 1. Because this actually returns a promise for undefined. So I didn't return anything. So it's kind of more.
That was my point, but you ignore return values. You don't care about the return value then in this particular instance.
Okay, but what if this threw an error somehow? Yeah.
Okay, that's where you go.
Yeah, that's why you don't want to necessarily ignore them.
So I have a question.
Yeah.
So you mentioned that you can change promises. So I presume you could do something along the lines of promise 1, then promise 2, so on. So if you do those things, how do you differentiate between what, and I'm presuming the results of, like, it's chaining, right? So
Yeah.
how do you differentiate between what is going into then as a promise and as a state?
What do you mean promise or state?
So this, you here, there's a single example.
Yeah.
And inside that you have written a anonymous function where username is the state, right? Or like say
Right.
a data object.
Right.
But if preceding this, there had been like other promises, and
So inside the then, you'll always have a useful object. It will never be a promise. You'll never unwrap your promise and find another promise inside of it. What we mean by chaining is something more like this. So let's go back. Maybe a user promise, and so we get the user, and maybe we're going to like console.log user, but then we're going to transform it. We're going to return user.name. So what we mean by chaining is that we have this new promise. Let's call then on it. Then function user name, and we can react to the result of that.
cool.
Does that make sense?
So whatever you return is always wrapped in a promise, is that?
Yes, because then always returns a promise.
Probably the basic example of promises is Ajax requests.
Ajax requests, yeah. So when I say something like get user, I really mean get user via Ajax. That's the idea.
So it looks like a Fluent API kind of follows the synchronous.
Yeah, it's a Fluent API, and it makes it so that you can say things kind of synchronously, right? Like this, then this, then this.
Is there that else?
There's a .catch.
That's
right.
Return value the first one.
Yeah.
Right.
Yeah.
Skipped ahead a little.
No, I mean, I think it's good. Right. So reacting with an exception, right? So remember, what I'm mainly trying to do here is point out the synchronous parallels, because I'm trying to convince you that promises give you back all those nice exception semantics you had in synchronous land. So, we have an exception that rolls up the stack into this user promise, the asynchronous stack, in this case. And then about handling an exception, right? We haven't actually talked about how to do this yet. So in synchronous land, you would do a try catch. In promise land, it's pretty similar. You say, I'm going to try and do the update, and then I'm not going to do anything if it succeeds, because that's not what we're not doing anything in the synchronous example. In reality, you probably would. But if it fails, my second handler, my onRejected handler, will react. And it'll just log. It won't rethrow. It'll just log. So this operation, just like this one, is considered to have succeeded. There's no exception propagating up the stack. There's no rejection propagating up the async stack. So the update promise here is actually fulfilled. Because just like up here, we said, oh, I got it. I handled it. So that's the analogy here. Does that make sense? So if update user fails, we're going to handle it.
And you're going to get the same behavior that if you don't define the reject handler, will go up to
Right. If you didn't define the rejected handler, then it would go up to update promise. Exactly. Yeah?
Is console not returning promise? Or?
No. And I'm not returning anything, so it's undefined. So
there's an error there.
So this will be a promise for undefined if there's an error. Not a very useful promise, but it's still a promise that's somewhat useful because it lets you know when it's all done and you can move on to the next step. The value is an important part of the promise, but it's not the only important part of the promise.
So you're saying if console log throws an error, that error does not double up?
No, that does. No.
Not if the anonymous function throws an error. The log function, that does not.
If the log function throws an error, then our handler, right, is considered to have thrown an error, right? It'd be just like if you, it'd be just like if you called throw right there.
So there's a difference between the update user function in the above and below, because the one below is returning the promise, correct?
Yes. Sorry, I should have emphasized like that more. But from the beginning, we've been in synchronous land where we have update user, and promise land where we have promise returning update user. If you were doing a WinRT API, then you would put async at the end of all your promise returning functions. Kind of verbose, but I don't know. Maybe it works. All right. The final kind of synchronous parallel case is just rethrowing the exception. You should kind of understand how this works by now, right? Just in the synchronous case, we catch the error, but we rethrow it with, a sanitized error message or something. In the asynchronous case, we say, I'm going to catch the error, I'm going to have a rejected handler, but I'm going to rethrow. And that propagates up so that the update promise represents a rejection with this message. Just like up here, it propagates up so that this whole scope ends up with an exception with update user bin. That one makes sense? Yes?
So internally, they just have a try catch block around every callback function. If
Yes.
the exception is rejected, if it's not, they'll just return a new promise that's fulfilled.
Yeah, exactly. There's a try-catch around both handlers.
First down to the function.
And for those of you who think that's slow, it's not actually. What's slow is code inside the try-catch block. But if you call a function inside the try-catch block, the function is not slow. V8 de-optimizes, like, if it sees a try-catch block in your function, it will de-optimize that function. But if you call a function from inside, it will not.
Let's say I make a typo and on the on-rejected promise, I return the new error instead of throwing it.
Yeah.
Then is that still, that update promise that gets returned, is that, it's still a rejected promise?
You tell me. I'll tell you afterwards, but you tell me first. No.
Probably not.
No. It's a return value. Whenever you return a value, it's a fulfillment. So it'll be fulfilled with an error. It'd be just like if this was inside a function and you put a return statement right there.
Even though you pass it into then undefined for the unfulfilled.
Right. Because
It's
remember,
returning, so it doesn't matter.
because this is just like the catch block, right? The catch block is this, and if you return from the catch block, it's a success.
Cool.
Cool. Good question. All right, so the final case, getting to your thing about returning a promise. This is like the case that doesn't quite have a synchronous analog, but it kind of does, in the sense of sequential operations are a very synchronous thing. If you're going to do several operations in a row, like prompt for the username, and then use that to update the user, and then refresh the UI, in promises, you can express this like this. You can say prompt for the new username. That gets you a promise for the name, right, in promise land. Then you get the name, and you return update user. So update user in promise land returns a promise for when this post against the server has gone through. And once that's done, it'll say, okay, then this whole thing is done, either succeeded or failed. I can move on to here. And if this whole thing has succeeded, including this guy, then it'll run this. Otherwise, it'll be an error, which we're not handling in this case, which is bad, but that's the idea. So when you want to, when you return a promise, it'll wait for that inner promise before it moves on to the next step. Yeah?
Do you have a problem if update user doesn't adhere to the promise philosophy?
No, you don't, right? So what if it returned, well, you do if it uses callbacks, but if it's completely synchronous.
I'm saying if you use an asynchronous callback, asynchronous.
Right. So interfacing between promises and callbacks is something we'll get into a bit later, but you can adapt between them very easily. But if it's not using promises, then this magic will not work. We have no way of saying like, oh, let's insert some extra function to do with the Node.js style or whatever. But if this returns a scalar, right, a non-promise, you have no problem, right? You can freely switch between promises and non-promises for the return value of this, because it'll just say, oh, I don't need to wait, I'll move on immediately. That's the idea there. Similarly, you can switch between returning rejected promises or throwing synchronous exceptions. And it'll be like, oh, you threw an exception, let me be rejected. All right, how are we doing? Okay, cool. So to see this in practice, now that we've got the theoretical foundations down, I think we've really got them down, given the good questions asked. So promises give you back exception propagation is what I want to show you here. So this is a callback example. This is, you bang this code out and you're optimistic, late night binge, you're like, oh, do these social graph things, it'll work great. And then you get a code review and your code turns into something like this and you're sad and you go cry in the corner. But then you think promises can save you because they can, because they turn that code into this. They say, get the user, then if that succeeds, get the best friend. Then if that succeeds, show the best friend. But if it doesn't succeed, then error. And if any of those steps fail, it'll go to the error. There's actually a slight typo here. I should have a separate line for the error, because right now, show best friend, if that errors, will not be caught by this. Sorry about that.
So there should be an extra line.
There should be an extra line. It should be .then undefined, comma, UI.error. I'm tempted to edit that right now, but I've never seen that work well in live PowerPoints.
Is there a common pattern? Like, or maybe our comments are undefined.
Yes, it's so common we have several shortcuts for it in real promises, in large libraries. I'm introducing you to the then primitive by itself, but one, we call it .catch, and then you just pass the error. You don't have to pass the undefined. There's another, which is .done, and what happens there is, if anything gets thrown, it'll just rethrow that so it hits window on error. So it's kind of like the last ditch. I don't have any graceful error handling. I'm not expecting this to throw, but let me know if it does.
Now that we've seen this, can we go back a couple slides and take a look at what we were doing to get here? Because it'll make more sense.
For sure. Okay. Let me answer that question first. Or
I have a question.
okay. Questions first, and then we'll go on to Safari.
You can go on.
So just to be clear, if get best friend in the middle failed, the promise returned by the second.
Oops. Oh.
The promise returned by the first then would be a rejected promise, which when you call then upon.
Yes. We'll
calls
skip.
The second, calls the error handler.
Exactly.
So is the normal pattern to put when you do things like that to only put the error handler at the very end?
Just like in synchronous code, you only put your catch at the outermost level, right? That's the beauty of promises, is you don't have to pass the errors all the way back up manually at each step. You can keep passing them around, and then when somebody says, I'm the application level error handler, or I'm the subsystem level error handler, I will add an error handler and deal with errors right here. Otherwise, they'll just propagate, just like exceptions would. That's the idea.
So my question was the same thing, because I was just wondering whether you're going to have error handler at each then, or you're going to have a catch-all error handler,
Yeah, no, you're gonna centralize your error handling at the places it makes sense, which is a rarity in async code in JavaScript.
If the final then is an error handler, how do I add helpful information to the error if I don't know which function failed?
Well, just like in try-catch land, right? Like you choose the granularity. So yes, if you don't know which one failed, you can do instance of checks, or you can add more catches at a more granular level, interleave throughout the code.
I can get enough information from the promise to determine.
Or you might have information in the thrown exception.
Right. I mean, it depends. Like, the thrown exception might be, user error, and you might say, oh, it's a user error. Let me display that to the user. Or it might be a syntax error, and you're like, crap. Let me log that and never speak of it again. So, that's the idea. Okay. So let me emphasize one more time, since I feel really bad leaving this slide up here with the kind of bad practice. So because this is in the mode where I put the error, I do success handler dot then undefined comma error handler. If this fails, this guy will not catch it, right? They should be thought of as kind of a pair that both react to this step. But if this step fails, then there's no next step to catch it. So it'll get lost. Or no, it won't get lost. It'll get propagated up to the ultimate promise.
So would you, in the corrected slide, would you leave off the UI error in the second call and add that then undefined UI error at the last call?
Exactly. Yeah. Okay. So that's the one big plus. You get back your exception propagation, and by itself, I think that's enough to make me happy. But the next cool thing is that because these things are first-class objects, you get something even more powerful than what you have with synchronous computation. Because you now have something representing the process of the computation, right? That's not really necessary in synchronous code because the process of the computation just happens and then you get back the result. But here you have these objects representing the process. And what's cool about this is you can write functions that then combine them, treat these operations as first-class objects themselves, and give you new things. So this all function, I'm not going to write these out, but you can imagine how you might write them. It fulfills with an array of the results, or it rejects if any of these reject. So if get user data returns a promise, and get company data returns a promise, all will create a new promise, and will fulfill it with an array if both of them succeed. It'll say, oh, here's the user data, here's the company data. Or it'll give you the rejection reason for whichever of them failed first. So that's just one example of a combinator that you can create now that you have access to this idea of first-class computation.
Is that why it's important that the functions always take a single value?
It's part of the reason. I mean, it's always, you want to be able to predict, just like you can with normal functions, one value. Another idea is any, right? So as soon as either of them complete, or if they both fail, then I'll reject with some combined aggregate error, right? So if you're going to try and do two things at once and just whichever of them finishes faster, let me know. That's the kind of combinator you would want. And you can see, I add a then handler to both of them that has special logic to go up and fulfill my return promise. Finally, this is a really cool example, a little bit advanced, but if we write this write file function to not only accept strings for the contents that it writes to the file, but also promises, then you can just pass it the results of this read file function directly. So read file returns a promise. Write file is like, hey, I accept promises. And you can end up writing code that looks almost synchronous, right? You don't have to say, wait for read file's results to come back, then pass it into write file. You can you treat them as first-class values, pass them between functions that accept each other, and you're good to go.
So in that case, wouldn't you do something like read file, then write file?
So that's exactly what I was saying you don't have to do, because you could write, you could code the write file function to do that for you, right? So then you could end up creating code that's just like this. That's all you need to do.
Sorry.
No, yeah, it's
No,
not just
within the implementation of write file, you wouldn't have to do anything with that?
Yeah.
right, or you would inside the implementation of write file you would use then.
Okay.
You would say if it's a promise, do then. Otherwise, just use it. Or you would use a reusable library function that lets you automatically turn functions into promise accepting functions.
So you'd be using instance of to see if it's a promise or not?
Yeah, or there's .then equals type of .then equals function, or
Which library?
Q is the one I maintain. Dojo was the original. Speaking of the original, so yeah, we've just gone down like a really technical road, and it was pretty fun. And wow, I guess that was a long time too. But I did want to back off and give you kind of a lighthearted story of how we got where we are today with JavaScript promises, because I think it's kind of exciting. It may just be being nerding out about the standards process and kind of the community and so on, but I think it's a cool one, and it's kind of inspirational. So the promises A+ story, as I like to call it. Back in the day, promises were essentially discovered around 1989 in programming language research. The E programming language by Mark Miller It was one of the original languages that used promises as first-class values. But they've made their way into so many languages these days, it's really a prevalent pattern. The F-sharp's async T was actually inspired directly by E's promises. And of course, async T became task T in .NET base class library. But it's also in Java. It's also in Python. First the twisted deferreds from that framework, but also in the language itself, this Python enhancement proposal. C++ 11, that language keeps growing new features. One of the features it grew is promises. And Dart, JavaScript's jealous kid sister, got promises as well. In JavaScript, the promises movement got started with CommonJS promises A. CommonJS was an interesting standards group. They were essentially a mailing list. And they were from the early days, before Node.js, before any of the server-side JavaScript stuff was really popular. They were saying, hey, let's do JavaScript on the server. What are some common patterns we can standardize on? So promises was one of the things they were trying to standardize on. And they got pretty far. They had this idea of promises A, which was inspired by Dojo. Dojo was the original implementation, and some others. But you can see the original message where I propose a promise API, or I promise to propose a promise API. The problem with promises A was that it was kind of poorly written as a specification. It was like 3 or 4 paragraphs of prose. Some of its most important points were some of the least emphasized, and some of them were just left off entirely, like promise chaining. It was really easy to misinterpret, and it had some extra stuff that nobody wanted, so people just kind of ignored and picked and chose what they wanted. And one of the unfortunate consequences of this was jQuery's promises, the $.deferreds. So this is a screenshot from me arguing on the jQuery bug tracker about how they should make their promises A compliant, just meet the basic spec that we already have out there. And we have this the answer where he's saying I'm very busy. I try not to troll me. It was close to 3 a.m. when I created this implementation, and I couldn't find the spec line that was important. And I'm like, God, okay, this isn't working. The essential problem with jQuery promises, right, from a technical perspective, was that they missed the entire async-sync parallel. They're just like, this is a nice way to put callbacks together. Let's put them in one promise object. So they failed essential reading comprehension on promises A and how it was supposed to give you this asynchronous primitive with a parallel to the synchronous world. So the only reaction to that was a giant Godzilla face palm. So I said, whatever, I can do my own thing. I went off and worked on Q with Chris Cole for a while. But I swore a solemn vow on the grave of all the callbacks that I laid to rest that I would not let this happen again. And so when this happened, somebody submitted this bug, or this pull request rather, to Ember, up and coming UI library, saying add the Ember.deferred mixin, which implements the promises A spec. Yeah, that was completely false. It was nowhere near that. It was like jQuery's, but even worse in many ways. So this activated my solemn vow. So after a double facepalm, I got angry and I wrote this long gist, or however they're pronouncing it these days, saying, you're missing the point of promises. jQuery is missing the point of promises. If you think jQuery is doing it right, you're missing the point of promises. And whoever this guy is who's submitting that pull request is definitely missing the point of promises. It wasn't actually a personal attack on those people, but it was like, here's the point. And a lot of it was the material we've covered about this is an abstraction for the correspondence between synchronous and asynchronous programming. It gives you back a call stack for the asynchronous world. If you don't follow these invariants, you're really missing the point and losing out on all the benefits. And at the bottom of the gist, I said, well, I just ranted at you for a long time, and thanks for reading, but let me be constructive. So I'm going to be back in a couple hours with a test suite for promises A. And so I actually did that. So I created this promises A test suite. And at the same time, one of the main maintainers of Ember.js, Yehuda Katz, also of Rails fame, got in touch with me. He's like, whoa, yeah, no, it wasn't my pull request. I want good promises. Let's do this right. So he went off and created an implementation called rsvp.js, which is actually one of the first passing implementations of the promises A test suite. And out of that, it got even better, right? We had this guy called Brian Cavalier who maintains a implementation called when.js, which you may have heard of, a promise implementation. He created a Git with me and him and a few other promise implementers saying, let's brainstorm. How can we improve this underspecified vague spec, this promises A that everybody keeps getting wrong? Can we clarify this? Can we create something that people can actually read and understand and be sure they're conforming to? And so, the first sketch of this promises A plus idea was born. Fast forward 6 months and we have a beautiful website with a great set of definitions and terminology and a spec algorithm requirements and a test suite that is way more extensive than the original promises A one that I put together. It's really impressive, and I'm pretty happy about that. But okay, so what? We went off and made a website. Well, it turns out that when you write a clear and thoughtful specification about something that people have been trying to do for a long time, but never really had anything to rally around, people really get excited about implementing that spec. I watch the stream of NPM modules that get published on my Twitter stream and feel like every day or two it's new promises A plus. And in fact, we have this big old list of implementations. This is just down to the L's. All of these patch the promises A plus test suite. All of these are completely interoperable implementations. We have over 30 of them, new ones streaming in every day. We have some in ActionScript, in Python, and Objective-C, and in another language which I don't remember the name of, but it's pretty esoteric. But people are so excited about this, they're implementing promises A plus in other languages. And what's great is because we only specify the core piece, the then method. Everybody can make their own choices about how pretty they want their API to be. We didn't say everybody should make their API look like Q. We just said make sure your then method behaves right. Meets this minimum standard of behavior so that we can all talk to each other. So I think this was kind of a key to our success. But it gets better, right? Because, in a DOM, they've historically had these horrible async APIs. Whether it be, returns this object, which you do add event listener success, add event listener error, and you have to clean up your event listeners. But those event listeners only happen once, and only one of them happen. Yeah, it sounds kind of like a promise, but in horrible, horrible disguise. Or XHR, which has on ready state change, right? Like the DOM has no idea what they're doing for the async APIs. So they kind of got in touch, and we worked out how can we fix this situation. Well, this is actually a screenshot of the DOM spec, dom.spec.whatwog.org, where they have standardized promises as part of the document object model in web browsers. And they have just shipped, as over the last 3 weeks, in Blink, which is Chrome, and Opera, and in Firefox. So these things are actually now part of the official WhatWog's standard, and they're shipping in browsers. And a lot of APIs are actually being designed specifically for the new DOM APIs to return promises. So all these asynchronous things, whether it be web audio or cryptography, or a new kind of foundational version of HTTP requests, they're all being designed for promises for their async operations. You can all work together with the same primitive that we have developed in user space. Even more so. So this is a slide from a TC39 meeting. TC39 is the committee that works on JavaScript, the language, and is evolving ECMAScript 6, the next version, and ECMAScript 7, the version after that. One of the members is very active in the promises community, and he's saying that one of the main themes for ECMAScript 7, the next version, should be concurrency, and it should in particular contain a promises implementation that's based on promises A+. It has all this other stuff that is very necessary for concurrency, event loop specification, and weak references, and so on. But they've noticed this work we've done in the community to create a specification and said, we should base our language primitive promises on this community specification. So I think that was pretty exciting. All right. I have some promises in your code slides on practical guidance, but it's been an hour, so let's leave that for the internet. You guys can check it out.
Yeah. I see you. I guess I'm assuming you're say, and wrap them with Q.
Yeah.
And I've seen a lot of code samples where people do that. Like Durandal actually tells you to do that.
Yeah.
It's much better. If you have chain jQuery promises, where do you wrap? Do you wrap each one? Do you wrap it?
You wrap them as soon as you see them. So the
you
moment
wrap
you do
each
your
one.
$Ajax, you wrap it.
Okay, but if you have nested Ajax calls,
You shouldn't like.
within
You should
the
wrap
within
it
the callback.
and then .then
Got it.
and then do the nested one inside the new Q promises then. And the reason for that is because jQuery promises only support case 1, the transformation. They do not support all of those error handling cases, the cases 2 through 4 I was going through. So if an error happens inside a jQuery handler, just hits window.om error. There's no way to recover. There's no way for you to put it into a rejected state. It's a complete loss. So that's very frustrating, and you should never have to deal with that. So just kill it with fire. Yeah.
So maybe this is a bit off topic, but in the last few days I have been trying to do something like, say, test APIs using